Hello students, welcome back to the discussion of the chapter Electrochemistry, and we are going to discuss the numericals based on Faraday's laws. So let us take one such numerical here. A current of 6 amperes is passed through AlCl3 solution for 15 minutes using platinum electrodes when 0.504 grams of aluminium is produced. What is the molar mass of aluminium here? So let us quickly write the data which is given to us. Electric current is given as 6 amperes. Time is given as 15 minutes, which is 15 multiplied by 60 seconds. That is 900 seconds. And the mass of aluminium produced is given as 0.504 grams. What we are supposed to find here is the molar mass of aluminium, isn't it? And the formula which we are going to use here is first the quantity of electricity passed, that is multiplication of I and T. And also the another formula which we are going to use is number of moles of electrons, which is equal to Q upon F. Alright, so let us go ahead with the discussion of the solution of this numerical. So now students, here if we simply want to find the quantity of electricity passed, which is nothing but product of I and T. So 6 multiplied by 900 gives us the answer as 5400 coulombs. And now let us find the number of moles of electrons passed through the solution, which is equal to Q upon F, that is 5400 upon 96500. So the answer for moles of electrons comes out to be 0.05596 moles. So students, these are the number of moles of electrons passed through AlCl3 solution. Now we need to find the molar mass of aluminium. For that, let us first of all find moles of aluminium produced. Okay. Now we are dealing with the deposition of aluminium, for which let us consider the reduction half reaction, which is nothing but Al3 plus 3 electrons gives you aluminium, that is Al, right? So from this particular half reaction we can say that 3 moles of electrons will deposit 1 mole of aluminium, isn't it? Therefore, we have already found the number of moles of electrons, isn't it? That is 0.05596. So many moles of electrons will deposit how much of aluminium, which is precisely given by 0.05596 upon 3, which gives us the answer as 0.01865 moles of aluminium. So these are the moles of aluminium produced in this particular numerical, okay? But now we are supposed to find its molar mass, isn't it? So can we say that 0.01865 moles of aluminium actually weigh 0.504 grams? This is given in the question, isn't it? Therefore, we are supposed to find the molar mass, that is mass of 1 mole of a substance, isn't it? So if I consider here mass of 1 mole of aluminium, it will weigh how much, isn't it? So again here 0.504 upon 0.01865, which gives us the answer as 27 grams. So we can say that the molar mass of aluminium is nothing but 27 grams per mole. So that was this particular numerical with solution, okay? Let us get into the discussion of another numerical. How many moles of electrons are required for the reduction of 3 moles of Zn2 plus to Zn, 1 mole of Cr3 plus to Cr, and how many Faradays of electricity will be required in each case? So let us quickly write the given. We are supposed to find moles of electrons and Faradays for reduction of 3 moles of Zn2 plus to Zn and reduction of 1 mole of Cr3 plus to Cr. Okay, we are supposed to find number of Faradays of electricity required. Okay, and here in the formula we are actually going to go ahead with the solution part, and we are simply going to write the reduction half reactions here for zinc as well as chromium. So reduction half reaction is Zn2 plus 2 electrons gives you Zn, and another reduction half reaction would be Cr3 plus 3 electrons will give you Cr, right? So considering these two half reactions now, let us go ahead with finding the moles of electrons and Faradays. So, first is with respect to Zn2 plus ions. We know that 1 mole of Zn2 plus requires 2 moles of electrons, right, from this particular half reaction. Therefore, 3 moles of Zn2 plus ions will require 6 moles of electrons, isn't it? And we also know that 1 mole of electrons corresponds to 1 Faraday. Therefore, can we say that 6 moles of electrons will correspond to 6 Faradays of electricity, isn't it? So, for reduction of 3 moles of Zn2 plus ions, we require 6 moles of electrons and 6 Faradays of electricity. Okay? Going ahead with respect to chromium. This is the reduction half reaction for chromium, right? Cr3 plus 3 electrons giving you Cr. So we can say here that 1 mole of Cr3 plus will require 3 moles of electrons, and also 3 moles of electrons will correspond to obviously 3 Faradays, right? Therefore, this answer is corresponding to zinc. For reduction of 3 moles of Zn2 plus, we need 6 moles of electrons and 6 Faradays. For chromium, we need 3 moles of electrons and 3 Faradays for reduction of 1 mole of chromium, isn't it? So that was with respect to the solution of the given numerical. Thank you all.